Hello and welcome to Math with Mrs. Becker. Today in Algebra 2, we are going to prepare for the Chapter 3 test. Now, what we go ahead and do together during this review, these are the concepts that you will see in the Show Your Work portion of the test. There is also one page of multiple choice. All right, let's get started. The first part says solve each system of equations and be able to show your work. Okay, so when you are solving a system of equations, you do have a couple of options. You can do what's called the substitution method, where you need one variable all by itself, or you can do the elimination method, where you add the two equations together and eliminate a variable. Okay, for this one, I want to do substitution because I can notice that y is really close to being all by itself. In fact, all I need to do is divide every single term by a -1. Now here, negative divided by a negative would cancel, so y is by itself. Positive 2x divided by -1 would be -2x. -2 divided by -1. Negative divided by a negative is a positive. 2 over 1 is 2. So what I did is I took this equation and I got y by itself by just eliminating the -1. I divided every term. I will no longer use this equation. Now, these are the two we are going to use. For substitution, I know that y is really -2x plus 2. So what I do is I go to the other equation and I substitute this in for y. I keep the 5x plus 6. Where the y is, I'll be making a substitution, equals -9. One thing that is important to realize, everything stays the same except for y. The 5x, the plus, the 6 equals -9. Where y is, now you fill in -2x plus 2. Now we just have a multi-step equation to solve. I can distribute the 6, so 5x, 6 times -2x is -12x. 6 times 2 is +12 equals -9. Now when I go ahead and combine like terms, 5x minus 12x is -7x, plus 12 equals -9. If I minus the 12 to the other side, -7x equals -21. Divide both sides by -7, x is alone. Negative divided by a negative is a positive. 21 divided by 7 is 3. But you're not done yet. Because when you are solving systems of equations, what you're actually finding is if you graphed these two equations, where on a coordinate plane would they intersect? We only know that x is a +3, so that means I would go to the right 3. I need to know the y value. Well, here's an equation that says y equals, so that's what I want to find. So y equals -2 times x. X is really a 3 plus 2. So y equals -2 times 3 is -6. -6 plus 2 is -4. Once you know your x and your y, you write your solution as an ordered pair. So the first example on the review would be +3, -4. Okay, now here's another one. One thing you really want to be careful with, check out the order of this. You want to make sure that you line up your x's and your y's. So before I even figure out what method I want to use, I'm going to rearrange this. So x plus 2y equals 4. 3x minus 4y equals 7. Okay, so again, you have to make sure that your x's are lined up and your y's are lined up. I want to go ahead and do elimination for this one because we did substitution last time. If I want to cancel y, this is -4, this is +2. Well, if I multiply this whole row by 2, 2 times 2y would end up being a +4y, so that would cancel. Now remember, you have to make sure that you multiply to every term. 2 times x is 2x, 2 times 2y is 4y, 2 times 4 is 8. Now I'm keeping the bottom the same. 3x minus 4y equals 7. When I add them together, I eliminated the y's. 2x plus 3x is 5x. 8 plus 7 is 15. If I go ahead and I divide by 5, 15 divided by 5 is 3. So I know that x is really a 3. But again, your final solution needs to be an ordered pair. So you go back to one of the original equations. Does not matter which one you pick. I'm just going to go to the top. X is a 3 plus 2 times y equals 4. If I minus 3, I would have 2y equals 4 minus 3 is 1. If I go ahead and divide both sides by 2, y equals 1 over 2, so you could write it as a fraction, 1/2, or if you put 0.5, I'd be totally fine with that. Okay, so what we have is the ordered pair 3 and 1/2. Okay, next one. I'm going to go ahead and do elimination again. This one, I could have easily done substitution here and gotten the x by itself, okay? But I know when we get to 3 by 3s, elimination is used pretty much in every step, so I thought that it was more important for us to practice that. When I'm looking at this one, I definitely want to do elimination. It would not be easy to even turn this into substitution. To try to get one letter by itself, I'd have to minus and divide, and it might get a little messy. So right away, as soon as I see that every variable has a number in front of it, automatically I just know let's try elimination. If I want to cancel the x's, because last time I canceled y's, okay, I can take 3 and 2 and make them both into a 6. But remember, one of them has to be negative. So if I multiply the whole top by 2 and the whole bottom by negative 3, I would end up with opposites in front of x. So if I take 2 times 3x, it's 6x. 2 times 5y is 10y. 2 times negative 16 is negative 32. Now if I multiply the whole bottom row by negative 3, negative 3 times 2x is negative 6x. Negative 3 times positive 3y is negative 9y. Negative 3 times negative 9 is a positive 27. Now when I go ahead and add them together, negative 6x, positive 6x is eliminated. For this reason, that's why it's called the elimination method. 10y minus 9y is 1y. Check this out, you guys. We are totally going to know our answer right away. If I take negative 32 plus 27, it's negative 5. So y is a negative 5. Now what you have to do is fill it back into one of the originals to find x. Last time I did the top, so this time I'll do the bottom, just to show you that you can use any equation you want as long as your math is correct. 2 times x plus 3 times y is a negative 5, has to equal negative 9. If I multiply positive 3 times negative 5, it's negative 15 equals negative 9. If I add 15 to the other side, negative 9 plus 15 equals 6. Divide both sides by 2. 6 divided by 2 is 3. Your final answer is an ordered pair. Make sure that you always have the x value before the y value. So my solution here would be positive 3, negative 5. So here are 3 examples for solving a 2 by 2 system of equations. It's just going to say solve, so you can use substitution like we did in the first example, or elimination like we did in the second 2. Okay, the next skill that we looked at in chapter 3 was graphing system of inequalities. Remember, when you graph an inequality, that's where you create a boundary line that may be solid and may be dotted. That boundary line separates your graph into 2 sections. One section is true, one section is false. If you're doing a system, your final solution is going to be wherever you ended up shading for all of the inequalities. So in this case, it's going to be for 2. Okay, y is by itself, so if I am graphing this top equation, after the x is a minus 3, so I go down 3. Your slope is the number in front of x, it's 1/2, so up 1 over 2, up 1 over 2. Now I look at the symbol to see if my boundary line is solid or dotted. This is going to be a dotted line. Remember, boundary lines need to go all the way through the graph. Now what we need to do is figure out, is this half true or is this portion true? Because remember, you always shade what's true. 0, 0 is not on the line, so I'm testing 0, 0. That means I can change the x and the y both to zeros. So y becomes a 0 is less than 1/2 times 0 is 0. 0 minus 3 is negative 3. So the statement says 0 is smaller than negative 3. Well, that's false. That means 0, 0 is in the false side because you always shade the true side. You shade the other side of the boundary line. Okay, now we're going to go ahead and do the second inequality. Y is by itself. Whatever's after x is where you start. It's plus 2, so up 2. Your slope is the number in front of x, and in this case it's a -1. So it's down 1 to the right 1, down 1 to the right 1. Check to see if it's a solid or a dotted line. This one happens to be a solid line. Now again, this orange line for me, this ends up separating your graph into two pieces. One side is going to be true, one side is going to be false. So in order to see which side to shade, you have to do a test point from the orange line, or our second inequality. 0, 0 again is not on the line, so I am going to test 0, 0. If I change y to a 0, greater than or equal to, -0 is 0, 0 plus 2 is 2. So my statement says that 0 is greater than 2. Well, that's false. That means 0, 0 is in the false side. Okay, so you shade the true side. So if 0, 0 is false, that means this side is true. Now your solution is wherever you ended up shading both times. So it's this area right here. So you'll want to either darken it, maybe make it a different color, but this area right here is your solution to that system. It is not a numerical answer. It is a shaded region on the graph. Okay, next part. If we step up our game and we go to x's, y's, and z's, intercepts are ordered triples where you have 2 zeros and 1 numerical value. So it says find the x, the y, and the z intercepts. Make sure you give them as ordered triples. So what that means is if I fill in a 0 for x and a 0 for y, this would cancel, this would cancel. To find the z-intercept, I would have to divide the -2. 12 divided by -2 is -6. Okay, so we have our z-intercept. Let's say I want to find the y-intercept. To find the y-intercept, I put a 0 in for x and z. This is what I would have left. 6y equals 12. Well, in order to get y by itself, I'd have to divide by 6. 12 divided by 6 is 2. There's your y-intercept. To get your z-intercept, you put in zeros for y and z. So the y and z would cancel. They would become 0. What you would have left is 3x equals 12. To solve for x, I'd have to divide both sides by 3. 12 divided by 3 is a 4. So here are your x, y, and z intercepts. Again, order triple means you have x, y, and z within parentheses. All right, backside. One really fun skill that we looked at in Chapter 3 is graphing ordered triples. In order to graph ordered triples, you not only need an x-axis and a y-axis, but they also added in a z. When they did that, they kind of made everything a little crazy. You are used to x being side to side. Not anymore. Now, x is diagonal. You need to picture this as going forwards. This is going backwards. So you will start at the origin. This is forwards. This is backwards. Now, side to side, that is the y. If it's positive, you go to the right. If it's negative, you go to the left. Z is my vertical axis. It runs up and down. This is up. This is down. Okay, so what you're going to do is look at every ordered triple. The first value tells you how you travel on the diagonal, forwards or backwards. The second value tells you if you go left or right on the horizontal axis. The last value tells you if you go up or down. Notice this is called coordinate space. Coordinate space, they do not have little tick marks for you. What they want you to do instead is go ahead and show the path that you take. Okay, so you're finding approximately where that point would fall. So if I am looking at A is positive, so I'm going to go forwards on the diagonal. Then I'm going to go to the right, and then I'm going to go down. So I go forwards 2 units, cut to the right what I feel is 3, go down 4. The big thing is I can see that you went forward, right, down, label. So that's A. Okay, now the next one. I'm not going forwards or backwards on the diagonal. Negative for the second value, so I go left 2 and up 1. So don't go forwards, backwards. Go to the left 2, up 1. I feel like that's a pretty good approximation where B would be. C, 1, 1, 1. So forward on the diagonal, head to the right, and up 1. So forward, right, up. Check that. I ended up right back at the origin. Okay, let's go ahead and look at the very, very last one. Negative for the x, so I'm going backwards on the diagonal. 0, so I'm not going left or right. Negative, so I'm going down. So I'm going back 3 units, not left or right, and down. So again, the main thing here is when you're graphing an order triple, you have to show the path you take. It's always x, y, and z. First value, forwards or backwards on the diagonal. Second value, left or right on the horizontal axis. The last value, up or down on the vertical. Okay, now we did a lot of this. Okay, all last week we spent time solving 3x3 systems. So hopefully you've got it down to an art form where you can totally rock this. Okay, here's one example just to make sure we've got it. What you do if it's a 3x3. Step 1, you pick 2 equations and you cancel a variable. The first thing that I notice is the top is a negative 2z and the bottom is a positive 2z. So right away I'm going to say, all right, let's take the top and the bottom and let's cancel z. I can cancel z by keeping them exactly how they are and adding them together. 1x and 3x makes 4x. 1y and 4y makes 5y. Negative 2z, positive 2z is 0. 10 plus negative 10 is 0. Now your next step, you have to use the middle because you need to use a separate set of equations. So I need the middle with either the top or the middle with the bottom. I'm going to do the middle with the bottom because I have to cancel z again. You always have to cancel the same. The reason why I chose the middle with the bottom is because I already have 1 negative, 1 positive. I just need to make them the same number. And I can do that by multiplying the whole middle row by 2. 2 times 8x is 16x. 2 times negative 9 is negative 18y. 2 times negative z is negative 2z. 2 times 5 is 10. I'm keeping the bottom the same because my goal here was to cancel z. So now when I add them together, I'm just going to go ahead and put it over here because it will give me my 2 by 2. 16x plus 3x is 19x. Negative 18y plus 4y is negative 14y. The z's cancel. Negative 10 and a positive 10 make 0. Now when I look at this, immediately I was like, oh no, those do not look like nice numbers at all. Okay, but if I go ahead and I want to cancel y because one's positive and one's negative, if you're like, I'm not sure a number that 5 and 14 both go into, you can always just multiply them by each other. The signs are already different, so if I multiply the top by 14 and the bottom by 5, both ways, this would be 14 times 5 and this would be 14 times 5. So we know we're going to get the same value. This is positive, this is negative. So if I take 14 times 4, this is 56x plus 14 times 5 is 70y equals 14 times 0 is 0. Now I multiply the whole second row by 5. 5 times 19 is 95x minus 5 times 14 is 70y. 5 times 0 is 0. So notice positive 70, negative 70 cancels. If I take 56 plus 95, I have 151x equals 0. Well, if I divide both sides by 151, 0 divided by anything is 0. So x has a value of 0. Now to see what y is, you go ahead and put it back into one of the original equations. So if I go 4 times 0 plus 5 times y equals 0. Now notice I filled in the x. I only have one variable left, so I'll be able to solve for y. 4 times 0 is 0, so I have 5y equals 0. If I divide by 5, 0 divided by 5 is 0. Holy smokes. Now I know 2 variables, so you go to an equation that has 3. X is 0 plus y is 0 minus 2 times z equals 10. Well, these are both 0, so it's really negative 2z equals 10. If I divide both sides by a negative 2, Positive divided by a negative is going to give me a negative. 10 divided by 2 is 5. So my solution is an order triple. X is 0. Y is 0. Z is negative 5. That can totally happen. This is actually a z-intercept. Kind of cool. All right, last type of question that you will see in the show your work portion. Sally has $50 to buy pizza. A small pizza is $4.50. A medium is $7. And a large is $10.50. Write an equation containing 3 variables to represent the amount of each pizza she could buy. So we have $4.50 per small plus $7 per medium plus $10.50 per large, and Sally has $50 total. So here is an equation that contains 3 variables, small, medium, and large, and it shows us how much Sally has. Now we need to use our equation. Use your equation to see how many smalls Sally can buy if she purchased 3 large. So L equals 3, and 2 medium. So M equals 2. Sorry, this is going to bug me. Okay, so how much she could buy. So if I go ahead and I fill those in, $4.50 per small. She's getting 2 mediums at $7. So I'm replacing M with a 2. $10.50 per large. She's purchasing 3 larges. She has $50. Well, if I go ahead and do the calculations, $7 times 2, this is $14. $10.50 times 3, this is $31.50. So I have $4.50 per small, plus if I combine these, it's $45.50 equals $50. If I minus $45.50, $4.50 per small, 50 minus 45.50 is 4.5. We're talking about money, so that's 450. If I divide, how many times does 450 go into 450? 1. So Sally could get, with her $50, 3 large, 2 medium, and 1 small pizza. Those are all of the concepts that you will see in the Show Your Work portion of the Chapter 3 test. Again, there is 1 page of multiple choice that also goes with the test. I hope you guys had a great time reviewing, and I look forward to talking to you soon.